Good afternoon, everybody. I will start today on the chapter about fertility, and I just wanted to emphasize that this coming Tuesday, it's going to be exam 2. So we covered chapter 2 about theories of demography in our after exam 1. And also we finished last class, chapter 3. And we were expected to have these 2 lectures on fertility before exam 2, but we are starting it just today. And today we will still have quiz 8 open. And then next Tuesday, we're gonna have exam 2. So exam 2 is gonna cover Chapter 2, about theories of demography. Chapter 3, the sources of demographic information, and all extra material that I added to the slides. For example, the gerrymandering content is not in the textbook, but it's part of this lecture. And then chapter 4, until the point that we reach today, right? So until what we reach today, it's going to be part of exam 2. And on Thursday, March 18th, there will be no class. That's a redefined day by the university. So we will have again in class here just on Tuesday, March 23rd, okay? And we will continue on the chapter about fertility. And in this topic about fertility, here in the website, there is this information, the lecture, and also there is this zipped file, compressed file. If you uncompress it, you're gonna have 2 Excel files that I show you in Excel how to calculate the rates that I'm gonna talk in the lecture, right? And so if you uncompress this file here, you're gonna get this file that's pretty much getting data from Brazil, the female population by year and age group, and the live births by age of the mother and year, and then you can estimate the age-specific fertility rates and generate this graph here. And for the US, I use data just for 1 year, 2012, and I also get information about women by age group and number of births of women by age group, that we can also estimate total fertility rate, but I'm gonna have more specific information that I'm gonna explain as we go along this lecture. And here in this table for the US, we have the estimation of several different rates in fertility and reproduction that can also be used to generate graphs. So I will go in detail in this Excel, specifically even more about the US, because it has it shows an example of estimation of a series of rates that I'm going to discuss in the lecture here. Yeah.
For the assignment that we turned in, paper.
Yeah, assignment 1. I think by this coming week, since we won't have in-class classes, I will have time, and then I will post the grade for assignment 1 on Canvas. So that was the question, when I'm gonna grade assignment 1. So by this coming week, I will post the grade on Canvas. And as I said, you can get up to 3 points in that assignment 1, okay? Cool. Any other questions? So let me just start here. Let me see if I can see the chat. I cannot see the chat. So if you guys from home want to ask any question, just unmute yourself and ask the question. So on this lecture about fertility, the overall lecture is subdivided into this introduction, where I'm going to talk about major concepts and indices, indicators of fertility, how to measure fertility. And when I finish this topic here, that's when I'm going to show you exactly how to do those estimations and those calculations in Excel. So here is pretty much a basic about how fertility is understood and how we can measure it. And I'm going to show examples, real examples, in those two Excel files that I just showed you. And then afterwards, I'm going to talk about this framework for predicting fertility. The idea is this is kind of linked to the theories of fertility. Whenever we see oscillations in fertility, we try to understand what are the reasons, what are the factors that made fertility increase or decrease in a specific country in a specific year. So we're going to use this framework or this background or this theoretical background to understand changes in fertility. So it's pretty much trying to think, what are the factors explaining fertility? And this is using this theoretical framework developed by demographers in these previous decades. And then I'm going to show you examples of how fertility has been changing over time, so trends and patterns of fertility in the world and also in the US. And in the US, showing specific cases of adolescent fertility, non-marital fertility, and childlessness. So these are topics that I will cover here, specific in the US. And then a final section about male fertility that's still not really well studied in the top by demographers. And the textbook emphasizes that it's important now to also deal with male fertility. So on the first topic about like an introduction to fertility, intercourse, conception, and fertility are all influenced by social and cultural factors. So whenever we're talking about fertility, we are talking about women having babies, and fertility is going to be influenced by intercourse of couples in a specific country in a specific year, and about the levels of women and men using contraception. And all these aspects here, intercourse, contraception, and fertility, there are several factors that influence them. And those factors can be social and cultural factors. And that next topic that I'm going to talk about, the framework for predicting fertility, is exactly discussing a little bit more in detail what are these possible factors that influence the levels of fertility. Okay? As we have been debating, like that was really clear since the beginning of this course, and I talked to you about the Lexis diagram, that we can do analysis in demography for a specific time point, or we can follow people over time. In fertility, we can also do all different kinds of analysis. If I collect data for a specific time point in a specific country, I will have a period analysis of fertility. If I'm collecting data about how many children women are having, for example, in a specific country in a specific year. So that's about a particular point, a particular period of time. And this perspective is also called cross-sectional because I'm taking data for all women in a specific place in a specific year, and this woman of all these different ages. So they were born in different years. So I'm going across all these different sections, all these different cohorts of women that were born in different years. Now, in this specific time point, I will collect information about all of them. So it's called period because it's one specific time, but it's also called a cross-sectional perspective because I'm going through all these different sections, all these different cohorts of women that I have in a specific country, in a specific year. The cohort analysis, it's when I try to understand changes in fertility patterns and I try to follow women through time. So I try to follow the patterns of fertility of a specific cohort, of a specific group of women born around the same time. And I try to understand how many children they are having throughout their reproductive years. And reproductive years here, usually standard, we calculate from 15 to 49 years of age. Microanalysis in fertility, we will try to understand what are the individual factors that are making people have more or less children, or more specifically, what are the characteristics of women that make them more or less likely to have children. The macro analysis, we will try to look at the aggregate level. What's the level of development of a country, urbanization percentage in the country? What are these major characteristics of a country that make people want to have more or less children? So just to emphasize here, all these different types of analysis in fertility can also be done for mortality and migration as well. We can also do analysis of mortality change or mortality levels in pattern in a specific time period. We can also follow different cohorts to see how often people are dying. We can also try to understand what are the individual characteristics of people that live longer or don't live as long. What are the characteristics of countries that make people have better health outcomes? So these different types of analysis here, what is important to emphasize is that we can do it for all three demographic components: fertility, mortality, and migration. Okay? And as I mentioned in the previous class about the sources of demographic information, I was talking to you about what exactly is death, what exactly is birth. So we are trying to explain these basic concepts. And then we talk about stillbirth, we talk about abortion, we talk about miscarriage. Always, whenever we are talking about these demographic concepts, it's important to explain what exactly they mean, and it's important to explain their meaning, their concepts, so we know exactly how to measure them. So fertility is the actual production of male and female births. So whenever you hear the word fertility, you are trying to measure how many men and women were born in a specific country, or how many boys and girls were born in a specific country. Bless you. So fertility, we are counting both male and female births. When we are talking about reproduction, we are actually counting only female births, only how many girls are being born. So whenever I talk about fertility and I get those indices, these indicators, I want to see if a woman, like on average, women are having at least 2 children. Because then those 2 children will replace the woman and the partner. Reproduction, I want to know if on average women are producing at least 1 daughter, because that daughter will replace her later on in the production of children. Fecundity is the biological capacity of producing live births. So that's more related to biology. The term fecundity here, it's not used in all those names of indicators in demography because it's more about the biological capacity of women producing babies, and also of men, of course, to be able to have babies as well. And if you know any Latin language, I mean, that's really in Spanish or Portuguese, the term fertility and fecundity are exactly the opposite. So fertility, the correct word in Spanish would be fecundidad, and fecundity would be fertilidad. So it's exactly the opposite there. But in our case, fertility and reproduction are the major concepts that matter to us here. What are these childbearing years, or also what is called reproductive years? Reproductive years for women, the standard is that we calculate the rates, the fertility and reproduction rates for women between the ages of 15 and 49. These are the main ages when women are able to give birth. Oh, but I know stories of women having children below the age of 15 or above the age of 49. Yes, there are women having children below 15 and above 49. But overall, the chances of having children are higher between ages 15 and 49. And demographers use this standard to compare several countries throughout the history, right? So usually we calculate the rates between 10 and 49. In some cases, when adolescent fertility is high, we can also calculate the rates from 10 to 49, okay? But we usually do 15 to 49 as a way to standardize our measures and compare these estimates over time across countries. Yeah, sometimes the age group of 15-44 is also used. So I mentioned if adolescent fertility is high, we can use 10 to 49. On the other hand, in developed countries, when really few births happen to women between 45 to 49, maybe you might want to calculate these rates only for the group between 15 and 44, okay? But usually, whenever we talk about reproductive ages of women, we are talking between the ages of 15 to 49. Some more concepts and terms in fertility studies. Like I said, fertility is the actual production of birth. Infertility, there's the fact of people not having children at all, either for voluntary or involuntary reasons. Fecundity is more related to biological factors, the ability to reproduce, to have children. And we think that we could have subfecund women, so those who are definitely sterile, probably sterile, semifecund, and fecundity indeterminate. And those who don't have, for any biological reason, no possibility of having children, they are sterile, so that's an example of a woman having infecundity. And also, there are specific time points in women's life that make them more or less likely to have children. So, at the beginning of the female reproductive period, the first menstrual flow, known as the menarche, is an important information for us to know when women start to be able to have children. Menopause, end of reproductive period, termination of menstruation, it's also an important aspect for us to understand the moment when women are not more able to have children. But even some not so biological factors, the postpartum period. What is the postpartum period? It's the period of infecundability following a pregnancy, a function of the duration and intensity of lactation. So women who breastfeed longer their babies, they have lower chances to get pregnant again while they are breastfeeding their babies. So that's what is usually called the postpartum infecundability period. Okay? So there's a period in which women cannot or have really, really low chances of having babies. They cannot have babies because they are breastfeeding their children. And those terms, postpartum infecundability, for example, it's going to be used later on by those demographers trying to understand the reasons why women don't have children. Some of the reason is the fact of them not having intercourse. Some of the reasons is because they might be using contraception. And some of the reasons because they are breastfeeding their babies. So they're not likely to have children during the postpartum period. The first example here of a rate trying to understand fertility is the crude birth rate. Is the simple, the simplest, let's say, a rate to understand the levels of births in a specific country. It's cross-sectional because you get data for a specific country in a specific year, and you pretty much get the number of births that happen in a population in a specific year, divide by the population in that year, and multiply by 1,000. Multiply by 1,000 because this division here would be really low, and we would not. So it's easy to interpret that. I hope that people can hear me from home. The crude birth rate. Why it's called a crude birth rate and not a fertility rate? Because the denominator includes man. And that's a major thing. I talked to you before in the previous slides. When we are counting male and female births, we are talking about fertility, births. I'm talking about the numerator. When I'm talking about female and male births, fertility. And that's exactly what we are counting here. But when I estimate a fertility rate, the denominator includes only women. Here in this denominator, I'm including women and men. So that's why it's called the birth rate. Reproduction. Reproduction, the numerator, it's only women. And the denominator, only women. So just to be clear, birth rate, the numerator, both male and female births, the denominator, both male and female population. Fertility, male, female births, only women in the denominator. Reproduction, only female births and only women in the denominator. Okay? So these are the differences between these three: birth, fertility, and reproduction rates. And that's important because if someone talks to you about birth rate, so you understand upfront that you are taking into account the male and female births in the numerator and the male and female population, the denominator. Fertility, male, female births, only women in the denominator. Reproduction, only female births, numerator, only women in the denominator. Okay? I could make a slide about that. I always think about it, but I think it's good in this sense for you guys to understand the logic while I'm explaining and you take notes. Example of crude birth rate in the US between 1950 and projections until 2100, done by the United Nations. So you get number of female and male births and divided by the overall population, multiplied by 1,000. And you have these trends that drop from 24 to below 12 per 1,000. So this is saying that back in 1950, out of 1,000 people in the US at that time, you had around 24 births between 1950 and 1955. And by 2100, the levels are going to be kind of like a little similar to what we have right now. Right now, it's a little above 12. It's going to be a little below 12, but it's the same thing. For every 1,000 people, we have 12 births here, a little above 12 births, and a little below 12 births. Now we have an example of a fertility rate. The first one that I'm going to show is the general fertility rate. Also cross-sectional period data, because we are getting data from one specific year in a specific location. Look at the difference now. Fertility, we are still getting male and female births in the numerator, and in the denominator now, only women, only the female population. And to be more specific, getting women in reproductive ages that we mentioned before, those between 15 and 49 years of age. Multiply by 1,000, because otherwise this rate would be really small decimal cases, so it's easy to read by multiply by 1,000. Some countries, some developing countries, might not have the information of how many women we had in that specific year between the ages of 15 and 49. Let's say that specific countries in specific years, they have just the number of births and the population in total. So in that case, we can calculate the crude birth rate that I showed before, but we cannot calculate the general fertility rate because we don't know exactly the female population between these ages. One way to approximate it is to just get the crude birth rate and multiply by 4.5 if the data only for the crude birth rate is available, right? If we don't have the denominator here to calculate the general fertility rate. This is, there are examples of, like here, the blue line, and it's related to the left vertical axis. This is births in millions in the US between 1920 and 2013. These are the blue curve here, the blue line is just the overall number of births. That's just the numerator. It's not a rate. It's just the absolute number. And just to show that this number declined around 1930s and 40s, then started to increase. And this period here is exactly after World War II. So that's the baby boom period. And then around mid 60s and 70s, it drops when we have more economic recession and so on that affects fertility. And then in more recent years, it increased again. It has some oscillations up and down, okay? The rate in this case, and this is an example of general fertility rate, the numerator are the number of births. The denominator, it's only women in reproductive ages. In the previous slide, the formula here are women between 15 and 49. For this graph, it's actually only women between 15 and 44, exactly because the US, a developed country, is the rate, the chances of women having children between 45 and 49 are really small. So these authors calculated only from 15 to 44, the denominator of that formula, and also the babies in the numerator these are actually all the number of births overall, but the denominator is only for a woman between 15 and 44, right? And what we see that here, the rate, the general fertility rate actually declined the same way that we saw for births, and then it increased exactly during the baby boom period, and then declined from the mid-60s until mid-70s, and then actually maintained constant. So if we look at this of the numerator, we think that, oh, the number of babies is still increasing a lot in the country. But if you take into account the size of the female population between 15 and 44 years of age, that rate has been pretty much stable over time. Right? So it's important to understand absolute numbers, in this case, only the numerator, but understanding the rate gives us a better idea of the overall amount of births, taking into account the female population. And the values of the rate, it's exposed here in the right vertical axis. And also multiplied by 1,000. So for example, here, around 2013, around, let's say, 62 births for every 1,000 women between the ages of 15 and 44, right? So that's how you read those numbers. But in terms of fertility rate, the general fertility rate is just one of them. There are several other rates that we can calculate related to fertility. The next one that's really used a lot by demographers to understand fertility levels and trends over time are the age-specific fertility rates, ASFR. These are birth rates of women according to their ages. And I said that usually the reproductive period of women are between the ages of 15 and 49. For the age-specific fertility rates, you break that age period into this 7 5-year age groups, from 15 to 19, 20 to 24, 40 to 44, 45, 49, right? So you pretty much calculate for each one of these subgroups of women, how many children they are having. So it's pretty much one rate for each one of these groups. These are age of women. And sometimes some countries might even calculate a single year rate. So you would get number of births of women who are 15 divided by women at the age of 15. So you could calculate the single year age groups, so for all these 35 ages from 15 to 49. But those rates would usually are not reliable because it's so like when you're talking about people reporting their ages, might not be so precise. So that's why it's better in this case to group the ages in these 5-year age groups. How do you calculate that? The age-specific fertility rate for each one of the age groups, you get the number of births that happen to women in that specific age group and divide by the overall number of women who are in that specific age group. And this notation here is standard in demography, ASFR XN. So what does it mean? That means, in this case here, for 15 to 19, how we would write the ASFR? It would be ASFR 15, 5. So we would go from 15 to 19, including 15. So it'd be 15, 16, 17, 18, 19. Okay? So whenever you see this notation, and it's sometimes difficult to understand it, but that's the way that it started and it has been done forever by demographers, is that this here is the beginning of the age group, and this one plus this is the end of the age group, right? So in this case, it would be 15, 5, but it's the end of the age group includes the first age. So it would be 15, 16, 17, 18, 19. The same thing for 20, 21, 22, 23, 24, and so on, okay? But I wanted to show you this notation here because it's standard notation by demographers. So you get the number of births that happened to women in specific age groups and divided by the number of women in those age groups. And then you are going to have 7 rates calculated for each specific location in each specific time point that you collected. And then you can plot those rates by the age groups. You can pretty much show these rates here in a graph in the vertical axis and show the age groups in the horizontal axis. When you do that, usually the curve that you're going to get of fertility by age is pretty much you're going to plot the 7 age-specific fertility rates, and usually you're going to have an inverted U shape, which is exactly this, right? So you pretty much got the age-specific fertility rates put in the vertical axis, and the 7 5-year age groups put in the horizontal axis, and you usually have this inverted U-shape form of these age-specific fertility rates. And this is data for Africa, the green line from 1970 to 75, and the purple line from 2005 to 2010. Just showing that overall, the fertility in Africa declined. And you also see that the chances of having children are higher among women between the ages of 20, 24, 25, and 29. And then it declines as women get older. And also younger women have lower chances of having kids. Okay? In this case here, it does have a little bit of a change in the pattern, because this decline here for 2024 was higher than this decline here from 25 to 29. Exactly showing a little bit of postponement in fertility. Women start to have children a little older. But this graph doesn't show that so clear. The graph for Europe shows that much more clear. First, the overall level is much lower. So these two graphs here have the same scale in the vertical axis, going from 0 to 350 births per 1,000 women in each one of these age groups. Also goes from 0 to 350. And then when you compare Europe, 1975 to 2005 to 2010, you see this huge drop in fertility in younger groups, mostly the one from 20 to 24, but also 25 to 29. And actually, you see the chances of having babies increasing among women 30 to 34 compared to previous years. So in this case here, you see a really clear change in the level, getting lower for younger ages and a little higher in these two age groups here, but also a change in the pattern. In previous decades, the green line is showing that women between 20 and 24 were the ones more likely to have children. As women start to invest in education and enter the labor market, they postpone marriage, they postpone having children, then the chances of having children in younger ages decline. And the chances of having babies at older ages start to increase, but also decline for those between 25 and 29, and actually increase only for 30 to 34, right? So these are women who are now investing more in education and labor skills and postponing marriage and postponing children. So these rates drop. And then they are a little higher in older ages, because that's when they decide to finally have children, okay? So this is a process that we're gonna always talk here about, postponement of fertility. Women are waiting at longer ages to have children, to first have their life more stable before they have children. The question is, when they reach this point here, will they have the amount of children that they wanted, knowing that now biologically they have lower chances of having children at older ages? That's the main question that demographers try to answer now. Is that this postponement in fertility, okay, maybe in the previous generation, women had 2 children in younger ages and they would stop. Maybe this woman here in more recent generations, they would just postpone it, but they still decide to have 2 children on average. The question is whether they will have time after this postponement, right? If they can catch up and have time, so the fertility is not going to decline as much. And we're going to talk more about this. This is related to what I'm going to discuss a little bit more afterwards on the quantum and tempo of fertility. Quantum is the overall decline of fertility, and the tempo is more related to this postponement of women having children at older ages. Here, for each area, in this case, continent, Europe, In each time point, in this case here we have 1970 to 75 and 2005 to 2010, we have the 7 age-specific fertility rates. Can we aggregate them in one single indicator? And that's what the total fertility rate is. And that's the most popular measure of fertility. It's also based on information for usually a specific country or in specific area in specific year. So it's cross-sectional. It can also be calculated for cohorts, so following people, women over time. And how exactly do you calculate it? So it's pretty much the number of births that a hypothetical group of 1,000 women would produce during their reproductive years. How do you calculate it? You pretty much just get the previous age-specific fertility rates that you just calculated before, these ones here, that you calculated with this formula, and you multiply by the width of the age group, and the width of the age group is usually 5, 15 to 19, 20 to 24, 25 to 29, and so on. And then you add everything. You just get each one of the age-specific fertility rates, multiply by 5, and add them all. Or you can just get the age-specific fertility rates, add them all, and multiply by 5. Since the width of these age groups is similar, it doesn't matter how you do it. And usually, we multiply the age-specific fertility rates by 1,000 because otherwise, these numbers here would get really small. But here we interpret that this is in Africa, 1970, around we saw for one between 25 and 29 years of age, 300 births for every 1,000 women between the ages of 25 and 29. That's how we interpret it, for every 1,000 women. The same thing will be done if we simply use the age-specific fertility rates that were previously multiplied by 1,000. And if we get those to calculate the total fertility rate, we're going to have this average number of babies that we would expect for women, for 1,000 women during their reproductive years. Reproductive years because we are talking about ages from 15 to 49. We can also estimate the total fertility rate just to get the average number of births to a single woman. In the case, you can just divide it by 1,000. Or if you had not multiplied the age-specific fertility rates by 1,000, then if you add them all and multiply by 5, you would get the information for a single woman, right? Let me show the graph here for the US, and then I will emphasize this interpretation here. Number of births per hypothetical group of women. In this case here, the total fertility rate I expressed, like I said here before, average number of births to a single woman, right? We either did not multiply the ASFR by 1,000 or we divided TFR by 1,000. And that's the average number of children that we saw in the US from 1911 to 2011. Then you have a decline until the 1930s. During the Great Depression, that you have a lot of difficulty economically for the population. The levels of fertility decline a lot. After World War II, you have economic development, more prosperity, and then fertility starts to increase. And then you start to see being more expensive to have children. You reach an energy crisis in the 70s that also puts fertility down. And then in more recent years, it increased a little bit. But even in the Great Recession in 2008, fertility declined a little bit. And I'm going to talk also about this now because of the coronavirus pandemic. It is expected also because of the increase in unemployment. It was huge in the world and specifically in the US as well, that will make fertility go lower. And people say, oh no, because of people staying more at home, that would increase the chance of people having babies. But the fact that you are at home is not affecting your contraception practices, is not affecting technically marriage. It can affect marriages in the way of people getting sick of each other and get divorced. And then that would affect fertility also negatively. But in this case, because it's not affecting contraception, it's not affecting marriage, and it is affecting their employment and economic well-being, they will tend to decide to have fewer children, right? And the impact on divorce would also have a negative impact on fertility. And what about that explanation that I had here? That's the number of births of a hypothetical group of women. When we get, and this is, I'm going back to previous lectures. When we get these age-specific fertility rates here for Europe, for example, we get them all, and this is data for a specific time point, 2005 and 2010. We get them all, add them, multiply by 5, because that's the width of each one of these age groups. What we are saying is, if we get a group of women and expose them to these age-specific fertility rates between the ages of 15 to 49, they would have, on average, let's say here, 2 children, 1.9 children per woman. But see, why is that called a hypothetical measure? Because this woman here, who are 15 to 19 in 2005, when they reach 5 years later, they will be 2024. They will be here. But these rates are not going to be the rates that they are exposed to, because they are another group. The group that was exposed to these rates were those women between 20 and 24, between 2005 and 2010. So when this woman here, the real woman, 15 and 19, during this time point, reach the ages of 20 to 24, this rate is going to be different. It's not going to be that. So when we do add all these rates here, multiply by 5, we are saying, like, let's make this theoretical, hypothetical exercise of getting a group of women exposing to these age-specific fertility rates, how many children they would have on average, right? Because these rates vary annually. And once a woman reaches older ages, their rate is going to be different. For example, if a woman reaches age 20, 5 years from now, their rates are going to be different than women who were 20 5 years ago. Okay? So that's why these are hypothetical measures for the total fertility rate. But it gives us a lot of information. And this graph here is a really clear example of how you can understand these oscillations in fertility rate, looking at economic aspects of that population. I showed to you in that chapter about the US, demographic trends in the US. And when I was talking about fertility, I was showing that the US has the highest total fertility rate among developed countries. And you saw also that the oscillation in fertility rates for Sweden also had some oscillations like those. And they kind of match exactly some events in terms of economic changes that happen in Sweden. Times that you have better economic outcomes in terms of employment and earnings, for example, you have higher fertility. Lower chances of work, lower fertility. People are rational, right? People decide to have children when they're more better off. Let's say that I don't have data about births and about women population for each one of these age groups, these 5-year age groups. So let's say that I have data only for the overall number of births and the overall population. So I just have the crude birth rate. One way to approximate the total fertility rate is to multiply the crude birth rate by 4.5 and then by 30. The crude birth rate times 4.5 is exactly the general fertility rate that we saw before. And if I do have the general fertility rate, so I have the number of births in the population of women between 15 and 49, but I don't have for each one of the age groups, I can just get the general fertility rate multiplied by 30 to get the total fertility rate. The period total fertility rates are usually preferred by demographers instead of the cohort, the ones that you follow women since the moment that they are born until where they are now. And of course, women when they are 15 years old until 49. Why you don't do that? Because it's more time consuming. It's harder to get historical information for this specific woman, but also because the total fertility rate gives us this time line of variations of fertility that you can see what happened in the country and affected the levels of fertility. Okay? So the total fertility rate calculated for data for specific years, they give us a better picture of that specific time point. And whenever we are talking about fertility, we usually say, we try to compare the level of fertility in a specific location, a specific year, to what demographers call natural fertility. What is natural fertility? It's the level of reproduction in the absence of deliberate fertility control. So it's how many children, on average, women would have if they were sexually active, they were not using any contraceptive method, and they were healthy. So by being healthy, they have more chances of having babies. So these demographers estimated that the natural fertility would be a number between 6 or 7 live births on average per woman. Take into account that they are sexually active, they are not using any form of contraception, and they are healthy. And 25% of completed fertility is due to genetics, the same thing as mortality. But a great portion of it, it's also due to social factors. And demographers, in practice, they usually take the fertility of the specific group of women, the Hilderites, as the natural fertility, as an estimation of natural fertility. The Hilderites back in the 1930s, they had on average 11 children per woman. And this specific ethno-religious group were formed in the early 16th century, and they have all the characteristics that I mentioned here to calculate natural fertility. Early age at marriage, a good diet, good medical care. Good diet, good medical care means they tend to be healthy and regularly engage in intercourse without contraception or abortion. Nowadays, almost all of them live in South Dakota, North Dakota, Montana, and Western Canada. You can even Google them. You can see more information about them in pictures and so on. But their rates from the 30s is taken as this measurement, as this standard of us to understand natural fertility. And why do we need that? To know where we are right now in specific locations, specific years, so we can compare. Because we can say, oh, this decline in fertility that we have been experiencing right now, that's the amount. What are the reasons? They are biological, genetic reasons, but also socioeconomic and cultural reasons. You could say, oh, but for example, in some developing countries, people marry early, even right now. People marry early, they are sexually active, and not using contraception. But the issue with most of these developing countries, they don't reach these 11 children per woman on average because they don't have a good health standards. They don't have good diet. They don't have good medical care, right? So that's why the Hutterites gives us this really important data. So let's compare. This is the age, the same thing as we saw before, the age-specific fertility rate, so number of births per 1,000 women for those same 5-year age groups. The vertical axis, the age-specific fertility rate, the horizontal axis, the age groups. So the Hutterite fertility between 15 and 49 for all these specific 5-year age groups, we see how high they go to 2024 and they start to decline. But when you compare this data to 2010 data from Mexico, US, and Canada, you see the huge difference, right? And just to start there, how do you calculate the total fertility rate for a single woman? You add all these age-specific fertility rates, multiply by 5 because that's the width of the age group, and you divide by 1,000 because they were previously multiplied by 1,000. You get exactly the 11 children per woman on average among the Hutterites, as I mentioned in the previous slide. For Mexico, in 2010, it was 2.2 children per woman on average, US 2, and Canada 1.7. So here's analysis of the drop in the level of fertility. But the graph shows us more than that. The graph shows us a difference in pattern. Among the Hutterites, the highest level of fertility were among women between the ages of 20 and 24. And then it started to drop afterwards. In Mexico, it's kind of equal for women between 20 and 24 and 25 to 29. So the level dropped and women tend to have children a little later. That's also the case for the US, and that's even more noticeable. Now women between 20 and 24 are less likely to have children than women 25 to 29. Postponement of fertility, taking longer to start having children. In Canada, even more clear, the change in the pattern dropped even more significant for a woman between 20 and 24. It's higher than 2024 for those women between 25 and 29, and even higher for a woman between 30 and 34, postponing fertility even longer. So what we see is that there is a drop in the level. We see the drop in the level here. And this is also clear in these summary estimations here of the TFR. But you also see a change in the pattern in the postponement in fertility, in which older ages start to have higher fertility than younger ages. Okay? So comparing the age-specific fertility rates to the natural fertility and the Hutterites fertility is taken as the standard help us understand these changes over time. Now we go to reproduction rates. Reproduction rates now, what's the difference now? We are going to talk only about female births, not going to talk about male births anymore. It's similar to the TFR, but it includes only female births in the numerator. And it's based on the concept of population replacement, that the daughters will replace their mothers in producing babies when they are in reproductive ages, when they are between 15 and 49 years of age. So the age-specific fertility rate from age X to age X plus N for female births is expressed by this notation here. Female births per woman in age group X, 2X plus N. And usually the width of the interval, it's 5-year age groups, the same thing, the same way as we have done before, 15, 19, 20 to 24, and so on. Let's say that I do have the information to calculate the total fertility rate. I do have the number of male and female births divided by women in each one of the 5-year age groups. But let's say that I don't have information only about female births. I just know the aggregate. In this case, you can get the total fertility rate and multiply by the female birth divided by number of births. And usually, one way to approximate this fraction of how many female births happen to birth overall. You usually get this fraction here of 0.488. What does it mean? That you have 48.8% of female births and 51.2% of male births. Where does this number come from? This number is based on the sex ratio at birth of most countries. And we talked about that before. The sex ratio at birth, the usual sex ratio at birth, when there is no preference for male babies, we would expect 105 boys being born for every 100 girls. So 105 boys for every 100 girls. Sex ratio at birth equals to 105. We saw China, Taiwan, South Korea, India, other countries with much higher sex ratio at birth, exactly because there is a male preference. So let's say this overall sex ratio at birth of 105. So how do you calculate the proportion of female births? The F fab here. It's going to be 1, which is pretty much 100%, minus the proportion of male births. How do you calculate the proportion of male births? Is the sex ratio at birth, 105, divided by the overall number of births. So what we are saying here is 105 male births for every 100 births of girls. 105 plus 100, you get here 205. Divide 105 by this, you get 51.2% of male births. 1 minus that, you get 48.8% of female births. If for those countries in which sex ratio at birth is much higher, we should just use another constant. So let's say I want to calculate the gross reproduction rate, but I don't have exactly the female births for each one of those age groups. I can approximate with this, but I'm not going to use 0.488 because that might be much lower in some Asian countries that have really high sex ratio at birth. So I just get the sex ratio at birth, calculate this, and then get this number and multiply by the total fertility rate to get the gross reproduction rate, okay? And the net reproduction rate is, we still only take into account female births, but we consider the factor of mortality among mothers from the time of birth of their daughters. Because we're pretty much saying that some of those people who survive, some of those women who are 15 years old now, they will not reach 20 years old. Some of those who reach 20 years of age will not reach 25 years of age. Some of those who reach 25 will not reach 30. So in this case, we are taking into account only female births But we are also taking into account that some women will not live all the reproductive years. They will not live from 15 to 49. Some of them will die before. So in this case, the net reproduction rate adds another dimension, adds the possibility of women dying before reaching age 49. So it's a more refined measure because we're pretty much saying, okay, I want to know the replacement of generation. I want to know if women are producing enough daughters to replace them in the next generation. But these women, not all of them will be alive throughout this whole period between the ages of 15 to 49. Some of them will die before 49. And we take that into account with this factor here in the formula. That's the new factor that we add in this formula. This 0.488 is that approximation in the case that we don't have only the female births. If we have information only about male and female births aggregated, we have to do this approximation here. If we have only female births, what we are adding to the formula is only this. So what is this term? That's the female births per woman in an age group. What is this big LXN? The big LXN and also the little L0, they will be, I will discuss them more in the mortality chapter when we talk about life table. But here what I want to explain is that those terms, they are measuring the chances of women reaching the next 5-year age group between these reproductive ages of 15 to 49. The big LXN is the total number of person years living in an age group, and the L0 is the number of people at age 0. So this proportion here, the big LXN divided by 5 times little L0, is the proportion of people who survive from age 0 to the midpoint of each one of the 7 5-year age groups. So what I'm saying is, what are the chances of women reaching the age group of 15 to 19? What are the chances of women reaching the age group of 20 to 24? Until the last one, 45 to 49. These terms here will give me that information, right? And that, again, it's going to be more clear. It's going to be clear in the chapter about mortality. And the width of the age group, we use the same thing as before, 5-year age groups. And I'm going to show this example of the gross reproduction rate and the net reproduction rate in that Excel table for the US. And then finally, we get the mean length of a generation. The mean length of a generation is the mean age of mothers giving birth to live daughters with the current age-specific fertility and mortality rates. So, taking into account the net reproduction rate, taking into account only female births, and taking into account mortality of women, what's the average age in which women are having babies or having female babies? And that's the formula that we calculate here. You get the same terms that we had in the previous one, but you multiply by the midpoint of the age group on each one of the 5-year age groups and divide by the net reproduction rate that you calculated before. So you have the same terms, the female births per woman in age group, the proportion of people who survive from age 0 until each one of these 5-year age groups. Okay? So I'm going to show you here the examples. So this is the simple example for age-specific fertility rates. So this is ASFR for Brazil. In this case, I got data from 94 to 2005 for the 7 5-year age groups. And this is the population of women in each one of these age groups and years. And then I calculate for the 7,890,286 women in 1994 between the ages of 15 and 19. They had 490,716 live births. Exactly between that age group in that year. So if we get this number here and divide by this number here, we get the age-specific fertility rate. So here I'm just dividing I'm just getting the number of births from here and divided by the population from here. And I'm not multiplying by 1,000 in this example. I could, but I'm not. How do you calculate the total fertility rate? It's pretty much you add everything here, you sum from this cell B4 to cell B10, multiply by 5, Y5, that's the width of each one of these age groups. So you see some oscillation of total fertility rate, actually increasing up to 1990, 1999, and then declining again in later years. And this is a lot of data, a lot of information, and you can create a graph using these age-specific fertility rates here. This graph here gets all messed up. I mean, just to show you that I can have a bunch of different years represented, but usually it's good to get fewer years and more distance to each other. So let's say 1980, 1990, 2000, 2010, 2020, right? But that's really simple to calculate age-specific fertility rates, but you need to have the population broken down by age group, by year, and the number of births for each by the age of the mother by year. And then this table here that I'm not going to have time to go through it all until the end of the class, but I do consider that our exam will cover until this topic of introduction, conceptualization, and measurement of fertility. I will not ask questions about these topics here, but I will ask questions about this, which cover until the mean length of a generation. Okay, so that's going to be the topic of that I will cover within fertility, but also the chapter about theories of demography and sources of demographic information. And this Excel table kind of starts in the same way as the one for Brazil. Here is for the US, and we have only data for 1 year, 2012. We have the same 7 5-year age groups, so 7 age groups for every 5-year interval. This information here about the midpoint of the age group is going to be used later on to calculate the mean length of a generation. So you pretty much just get the beginning of the interval from here, the beginning of the next one divided by 2. And you do the same here, 20 plus 25 divided by 2, and so on. 25, 30 divided by 2. That's the midpoint of the age group. It's always the same for these age groups here. The data that I highlight in yellow are cells that I got from other sources. In this specific case here, I got data from this textbook. So I have the number of women for each one of these age groups and how many births happen to women in exactly those age groups. So I have a total of 73 million women between the ages of 15 to 49 in the US and 3.9 million births to those women. If I get this number here and divide by this, is the age-specific fertility rate. I do all that. I sum all these rates, multiply by 5, I get the total fertility rate of 1.88. This exercise here is the same exercise that I did for the Brazilian spreadsheet. I can also have the general fertility rate that is pretty much just getting the overall number of births and divided by the overall number of women and multiplied by 1,000, right? I don't have here the crude birth rate, because the crude birth rate, we would need also the size of the male population. And then, so I will ask questions until the topic of mean length of a generation, because I covered that in the lecture. I will go back to this spreadsheet here next time that we meet in person. And then I will explain these other columns that are highlighted here. So on Tuesday, you have exam 2. Take on Canvas the same way that I did exam 1. On Thursday, following the university calendar, we don't have class because it's my birthday, so day to celebrate. And then we see each other again on the following Tuesday. Okay?
Do you have any Excel stuff on the exam?
Any what?
Will we have any of these Excel calculations on the exam?
Not calculations. You don't have to do calculations in the exam. You have to more understand the concepts. I will ask about concepts. Like, for example, the net reproduction rate takes into account what? Female births, female and male births, takes into account mortality or not. So that's what I'm going to ask you. What is the rate that takes into account only female births and mortality of women? Net reproduction rate. What is the one that takes into account only female births, but not mortality of women? Gross reproduction rate, right? So that's what I want you to know. You know, just understand the concept. Okay? So thank you very much. Have a great weekend, a great exam, and I see you guys in our next class. Thank you.